A very pleasant good morning to you all. Welcome back to Physics online class. Dear students, are you ready to listen the class? Good. Last class we have learned lesson 3. What's the topic? Thermal physics. Under that we have learned the concept of temperature, absolute temperature, thermal equilibrium, thermal energy. What are the characteristic features of heat energy and units of heat energy? From this, I gave some assignment. Have you all completed? Very good. Today, we are going to discuss about the effect of heat energy and expansion of substance in solids. Under that, the types: linear expansion, superficial expansion, and cubical expansion, and also the expansion of liquids and gases. Okay. What is the effect of heat energy? See, when we are heating the substance, we are giving the heat energy to the substance. What are the changes we can observe here? First of all, we can see the temperature will be increases. Okay, the temperature increases. The next one, the solid will become to liquid. Okay, change of state takes place when we are giving the heat energy to the substance. Change of state takes place. Solid will become to liquid, and liquid maybe it will be changed to gaseous state. Okay, and also we can observe that expansion of substances. Okay, atoms and molecules present in the substance will expand or vibrate, okay, from the original position. So expansion of substance takes place when we are applying the heat energy. So these are the effect of heat energy. Temperature rises, solid will become to liquid, and liquid means it will change to gaseous state, and substance will be expand. The rise in temperature will depends upon the following factors. Okay, so change in temperature is proportional to amount of heat energy supplied. How much amount of heat energy we are giving, according to that the temperature will be changing. Okay, so rise in temperature is proportional to amount of heat energy supplied, and also depends upon nature and mass of the substance. Nature means depending upon the physical and chemical properties, the rise in temperature will be, and also mass of the substance, how much amount of the substance we are taking. Okay, depending upon that rise in temperature will be. If you are taking a very less amount of substance, the rise in temperature is more. Okay, and the same time if you are taking a large amount of the substance, the rise in temperature will be less. Okay, so based on these two factors, rise in temperature is proportional to amount of heat energy supplied and nature and mass of the substances. Okay, expansion of substances, it will be takes place in all forms of matter. Okay, solid, liquid, and gases. Solid will expand, and liquid also will be expand, and gas also expanding when we are giving the heat energy. Okay, so what do you mean by thermal expansion? The change in dimension due to rise in temperature is called thermal expansion. So change in dimension, okay, dimension will be changing, or the size of this object will be changing due to increase in temperature is called thermal expansion. Okay, change in dimension because of the rise in temperature is called thermal expansion. Expansion of substance under the three types of matters will expand. Is it expansion in solid, expansion in liquid, and expansion in gases? Okay, first we are going to learn how the expansion takes place in solids. Okay, so in solid the expansion takes place in three different types. Okay, linear expansion, superficial expansion, and cubical expansion. Okay, linear expansion means the length of the object will be changing, and the superficial expansion, area will be changing, and cubical expansion means volume is changing. Okay, so in solids the three types of expansion takes place. What and all? Linear expansion, superficial expansion, and cubical expansion. See, when we are heating a solid, what will happen? In solid, atoms and molecules are tightly packed, isn't it? So when we start to heat, the atoms and molecules will gain energy, okay, will gain the heat energy, and it will start to vibrate, okay. Due to this vibration, the expansion or expansion will be takes place, okay. Extension of expansion, it will be smaller in solid than liquid and gases, okay. So when we are comparing these three states, gases will be expand more, and after that liquids, then last only solids, okay, because solids, atoms and molecules are closely packed to each other. So expansion is smaller in amount in solids than in liquid and gases, okay. The first type, what is linear expansion? Already told, linear expansion means length of the body changing, okay. So length of the body changes due to rise in temperature or change in temperature. If you are heating a rod, the length of the rod will be extending, okay. So depending upon the change in temperature, length of the body changes. This is called what? Linear expansion. It is also called longitudinal expansion. Linear expansion or longitudinal expansion. Linear expansion or longitudinal expansion. So now we are going to learn what do you mean by coefficient of linear expansion. See, coefficient of linear expansion, the ratio of increase in length of the body per degree rise in temperature to its unit length is called the coefficient of linear expansion. See, increase in length, if you are giving the heat energy, the length will be increasing, okay, per degree rise in temperature. For rising the temperature each and every degree, there will be changes in the length, okay. Ratio of increase in length of the body per degree rise in temperature from the unit length, okay. So that is called the coefficient of linear expansion. Here the SI unit of this coefficient of linear expansion is Kelvin power minus 1, okay. What's the SI unit of linear expansion? Kelvin power minus 1. Just see this example here. This is the rod. First, before heating, let us take L0 be the original length, okay. So L0 be the original length, okay. So after that, when we are applying the heat energy here, see here the length will be increases, okay. The change in length, let us take the change in length is equal to delta L, okay. For every degree rise in temperature, there will be increase in the length, okay. So the change in length, let us take delta L be the change in length, okay. So L0 be the original length and delta L be the change in length. Delta L be the change in length. Now you can learn the equation relating the change in length and change in temperature. So we know delta L denotes the change in length. L0 be the original length, okay. So the ratio of change in length by original length, okay, per unit length, it is proportional to this alpha L denotes the coefficient of the linear expansion. Alpha L denotes coefficient of the linear expansion per degree rise in temperature. So change in temperature delta T, okay. So delta L by L0 is equal to alpha L into delta T, okay. So here delta L change in length. L0 be the original length, okay. Before heating, L0 is the original length and delta T be the change in temperature, okay. So initial temperature minus final temperature minus initial temperature gives the change in temperature, and alpha L denotes the coefficient of the linear expansion, coefficient of the linear expansion. So the equation related to the change in length and change in temperature, delta L by L0 equal to alpha L into delta T. So next one we are going to learn what is superficial expansion. So here in the superficial expansion, there is an increase in area, okay. So the last one we studied increase in length, here increase in area, okay. There will be changes in the area of a object, okay. There is increase in area of a solid object due to heating. That is called superficial expansion. and another name area is changing, no? So it is called areal expansion. Okay, increase in area of the solid object due to heating is called superficial expansion. Now we are going to learn what is coefficient of the superficial expansion. Coefficient of superficial expansion means the ratio of increase in area of the body per degree rise in temperature. Okay, we are giving the heat energy to the substance, so the temperature will be increases. Per every degree rise in temperature, there will be the changes in the area. Okay, so ratio of increase in area of the body per degree rise in temperature to its unit area. Okay, from the original area to how much amount of area will be increased. Okay, that ratio is called coefficient of the superficial expansion, and the same unit, SI unit, is Kelvin power minus 1. Okay, here A0 be the original area of the object. After heating, this is the expanded portion. Okay, delta A be the extended area. Okay, increase in area. A0 be the original area and delta A be the increase in area of a object. Okay, so the equation related to change in area and change in temperature is delta A by A0 is equal to alpha A into delta T. Here delta A denotes change in area, A0 be the original area, alpha A denotes the coefficient of the superficial expansion, and delta T denotes the change in temperature. Delta A change in area, A0 be the original area, and delta T change in temperature, and alpha A denotes the coefficient of the superficial expansion. So increase in area per every degree rise in temperature to its unit area is called as the coefficient of the superficial expansion. Area increases means coefficient superficial expansion. Okay, or areal expansion. The third one is cubical expansion. So here, when we are applying the heat energy, the volume of a object is increases. Okay, increase in the volume of a solid object. Okay, increase in the volume of a solid object due to heating. Okay, increase in volume of a solid object due to heating is called a cubical or volumetric expansion. Cubical or volumetric expansion. Increase in volume of a solid due to heating is called cubical or volumetric expansion. So here we can learn what is coefficient of the cubical expansion. Here increase in volume. Okay, ratio of increase in volume of the body per degree rise in temperature to the unit volume. Okay, increase in volume of an object. If you are increasing the temperature or if you are giving the heat energy continuously, there will be change in the temperature, rise in temperature. Based on that, the volume will be increases. Okay, from the original volume or unit volume. For each unit volume, how much amount of this volume will be increases. Okay, that is called as the coefficient of the cubical expansion, and this unit is Kelvin power minus 1. Here V0 be the original volume of an object. After heating, the volume will be expanding. So delta V be the change in volume. V0 be the original volume and delta V be the change in volume. The equation related to the change in volume and change in temperature, delta V by V0 equal to alpha V into delta T. What is delta V? Change in volume. V0 be the original volume and alpha V be the coefficient of the cubical expansion. Coefficient of cubical expansion. Change in volume, delta V, V0 be the original volume and delta T be the change in temperature, and alpha V denotes the coefficient of the cubical expansion. So what is meant by coefficient of the cubical expansion? The ratio of increase in volume of a body per degree rise in temperature to the unit volume. Okay, for 1 unit of volume, how much amount will be increases. Okay, per degree rise in temperature, that is called coefficient of the cubical expansion. So far we have learned the three types of expansion takes place in solids. Okay, what are the three types? Linear expansion, superficial expansion and cubical expansion. Now in this tabular column they have given the coefficient of the cubical expansion of some of the materials. Okay, and this values here. First, name of the material. For aluminium, the coefficient of cubical expansion is 7 into 10 to the power minus 5. And brass, 6 into 10 to the power minus 5. For glass, 2.5 into 10 to the power minus 5. And water, 20.7 into 10 to the power minus 5. And for mercury, it is 18.2 into 10 to the power minus 5. Next we are going to learn how the expansion takes place in liquids and gases. When we are heating a liquid or gases, what will happen? The atoms in a liquid or gases will gain the heat energy and are forced. Okay. So due to this force, the expansion takes place here. So this is the expansion varies from substance to substance. Okay. Depending upon the substance, the expansion will vary. And here liquid will have more expansion than the solid substances. Okay, liquid will have more expansion than the solid substances, and gaseous substances has the highest expansion. Okay, gaseous substance has the highest expansion. So liquid will have more expansion than solid. Comparing to solid, liquids, the atoms and molecules are loosely packed, so it will be easily expand. Then gaseous, it will be, comparing to liquids, it is highly loosely packed, atoms and molecules. So the expansion is more in gaseous compared to liquid and solid. Okay, gaseous substance has the highest expansion. When we are heating a liquid, what will happen? The thermal energy will be supplied to the thermal energy will be partly used in expanding the container first. Okay, when we are heating, initially the container will get the heat, so the container will expand first. After that only the part of the energy is going to heat the liquid. When a liquid is heated, the thermal energy supplied will be partly used in expanding the container and partly it will be expanding the liquids. So what we observe may not be the actual or real expansion of the liquid. Okay. So when we are heating the liquid with the container, what we are observing, that is not a real expansion or not actual expansion in the liquids. In liquids we can define the real and expansion and apparent expansion. So in liquid we can explain the real expansion and apparent expansion. Apparent means what we can, it seems to be. Okay, so that two types of expansion is here. Okay, real expansion and apparent expansion. When we are heating the liquids and gases, first the atoms in a liquid or gases gain energy and are forced. Okay, due to this expansion varies from substance to substance. When we are comparing with the solid, liquid will have more expansion than solid, and gaseous substance has the highest expansion. Gaseous substance has the highest expansion. When a liquid is heated, the thermal energy supplied will be partly used in expanding the liquid and partly expanding the container. So in liquids we can see real expansion and the apparent expansion. So what we observe may not be the actual or real expansion when we are heating the liquid with the container, because partly it will be used to expand the liquid and part of this energy will be expanding the container. So what we are observing, it is not a actual or real expansion of the liquid. So we can define the real expansion and the apparent expansion. What is real expansion? When we are heating the liquid directly without using any container, that expansion is called as the real expansion. Heating the liquid directly without any container. Okay, that is called as the real expansion. Expansion that you observed is termed as the real expansion. What do you mean by coefficient of the real expansion? The ratio of the true rise in volume of the liquid per degree rise in temperature to its unit volume. Okay. True rise in volume of the liquid per degree rise in temperature. When we are heating, the temperature will be increases, so that the volume of the liquid will be increases. Okay. Per unit volume, how much amount of this volume is increased? That is the ratio of true rise in volume of the liquid per degree rise in temperature. For every 1 degree rise in temperature, how much amount of volume of the liquid is increases. Okay. That is called as the coefficient of the real expansion, and its unit is Kelvin power minus 1. Okay. So what is real expansion? Coefficient of real expansion is defined as the ratio of true rise in volume of the liquid per degree rise in temperature to its unit volume. The unit is Kelvin power minus 1. The next one is, what do you mean by apparent expansion? When we are heating the liquid without using the container is not possible. You all know that. Okay. Always you will heat the liquid with the container. Okay. It is not possible without using the container to heat a liquid. So when we heat the liquid, part of the thermal energy used in expanding the container and the part of the energy used in expanding the liquid. Okay. Part of the energy used to expand the container and the part of the energy is used in expanding the liquid. So the expansion of a liquid apparently observed without considering the expansion of the container is called as the apparent expansion. Usually we won't consider how much that container is expanding, is it? Only we will see how much amount of this water is raised, how much amount of this volume is increased. So we won't consider the expansion of the container. So that type of expansion is called as the apparent expansion. Now we can define what is coefficient of apparent expansion. The ratio of apparent rise in the volume of the liquid per degree rise in temperature to its unit volume. That is without considering the expansion of the container. Only we are measuring that rise in volume. Okay, per degree rise in temperature. Each and every degree rise in temperature, there is the rise in volume of the liquid. Okay, to the original volume of the liquid. That is called as the coefficient of the apparent expansion, and its unit is Kelvin power minus 1. Okay. So this one we can prove experimentally. How to calculate experiment to measure real and apparent expansion of liquid. Okay. So we are going to learn the experiment. From that we can measure the real and apparent expansion of a liquid. In this experimental arrangement, first we have to take the container. Okay. And in this container, which liquid we are going to find the real and apparent expansion. That liquid you have to pour into a container. So that level first you have to mark. Okay, up to this level we filled. So here this level is marked as L1. Okay, this is the initial level of the liquid before heating. Okay, first we have to mark the level of the liquid, that is L1. So here the thermometer is already inserted here to measure the temperature. Okay. So when we are applying the heat energy, we can measure the temperature by using this thermometer. Okay. The liquid whose real and apparent expansion is to be determined is poured in a container up to the level of L1. Now what we have to do? We have to heat the container. If we start to heat, what will happen here? The container will expand. Okay, the container will start to expand. So what will happen when the container expands? So here the level of the liquid will be decreases. Okay, so because the expansion takes place in the container first when we are applying the heat. Okay, by using the burner we are applying the heat energy. The container will expand. So due to this expansion, what will happen? The level of the liquid will be decreases. The level of the liquid will be decreases. So that level, let us take L2. Okay. So due to the container expansion, the level of the liquid will be decreases. That is L2 be the level of the liquid after heating. Okay. Again further, if you are heating continuously, now what will happen? The thermal energy supplied to the liquid, okay, from the container to, it will be going to the liquid also. So what will happen? The level of the liquid again it will be rises. First when we are applying the heat energy, the container expand. That time the level of the liquid reduced, that is L2. Again we are continuously, if we are applying the heat energy, the level of the liquid will be rises. Okay, that level it is marked as L3. Okay, the final level of this liquid is marked as L3. Initially the container receives the thermal energy and it expands. Now the volume of the liquid appears to be reduced. That level only we marked L2. And further heating, what will happen? The thermal energy supplied to the liquid through the container. So the level of the liquid again increases, that is L3. Now we can see the difference between the level L1 and L3. So this difference L1 and L3, it gives the apparent expansion, and this difference between L2 and L3, this two difference will give the real expansion. Okay, so L2 and L3, this two difference will give the real expansion. We can go through all the points what we learned in this experiment. First, the liquid whose real and apparent expansion is to be determined is poured in the container. That level we have to mark as L1. Now what we will do? Heat the container and the liquid using the burner. It starts to heat. What will happen? The level of the liquid will decreases. Initially the container receives the thermal energy and expands. So volume of the liquid appears to have reduced, and this reduced level we have to write L2, mark as L2. Again, if you are further heating, the thermal energy supplied to the liquid through the container. As a result, expansion of the liquid takes place. So that final level of the liquid rises to L3. That level you have to mark as L3. Now we can see the difference between the level L1 and L3, it gives the apparent expansion. The difference between the level L2 and L3, it gives the real expansion. Okay, real expansion, the difference between the level L3 and L2, and the apparent expansion, difference between L3 and L1. Next we are going to learn the three fundamental laws. Okay, these laws related to pressure, volume and temperature. Okay, it's very important definitions. Okay, Boyle's law, Charles' law and Avogadro's laws. Okay, these three laws are called fundamental laws of gases. It is related to pressure, volume and temperature. So first we are going to learn what is Boyle's law. See, Boyle's law states that when the temperature of the gas is constant, the volume of a fixed mass of a gas inversely proportional to its pressure. See, temperature is kept constant. We are keeping the temperature at one constant temperature, that is 25 degrees Celsius maybe. That volume of fixed mass of a gas's volume is inversely proportional to pressure. That is, volume increases means pressure will be decreases. That is the meaning of inversely proportional. Okay, volume and pressure inversely proportional. What is the condition here? Temperature remains constant. At the constant temperature, the volume of a fixed mass of a gas is inversely proportional to pressure. So we can write this equation P proportional to 1 by V. Volume and pressure inversely proportional. That's why 1 by V. Pressure increases, volume decreases. Okay. So these two also inversely proportional to each other. Okay. So this is Boyle's law. Okay. When the temperature of the gas is constant. Okay. Temperature is constant. The volume of a fixed mass of a gas is inversely proportional to pressure. You can write PV is equal to constant. Okay. PV, pressure and volume is equal to constant. Listen this picture here. The container, it is filled with the gases and it is fitted with the what? Airtight piston here. Now if you are releasing the piston in the upward direction, what will happen? The volume of this gases will be increases. Okay, volume of the gases increases. So here what will happen? The pressure. Okay, so when we are releasing this piston in the upward direction, so what will happen? The pressure of the gases will be decreases. Volume increases. When we are moving this piston up, volume increases and the pressure will be decreases. See here, when we push this piston downward direction, volume will be decreases. See here, only this much volume is there and pressure will be, okay, pressure of this gas will be decreases. Okay, volume decreases and the pressure will be increases. Okay, volume decreases. When we are moving this piston in the downward direction, the volume will be decreases and the pressure increases. Okay, because only the small area is here, is the small volume, so the pressure of these atoms and molecules will be increases. So next law, Charles law. This Charles law was formulated by French scientist Jacques Charles. Okay, Charles law formulated by Jacques Charles. What he told, when the pressure of a gas is kept constant. The previous Boyle's law, we kept temperature is the constant. But here, you have to keep the pressure constant. Okay, pressure is constant. The volume of a gas is directly proportional to temperature. Volume directly proportional to temperature. Okay, what is the condition here? The pressure is kept constant. The volume of a gas is directly proportional to temperature. So, V proportional to T. Here, volume increases with increase in temperature. Okay, volume increases with increase in temperature. So, V by T is equal to constant. Okay, volume by temperature is equal to constant. If you are taking the ratio of volume and temperature, you can get the constant value. So, Charles' law states that the pressure is constant. Volume of a gas is directly proportional to temperature. What is the meaning of directly proportional? Temperature increases, volume also increases. Okay, so this is Charles' law. So next one, Avogadro's law. Okay, Avogadro law, here what it states that at a constant pressure and temperature. Here pressure and temperature also kept constant. In that time, the volume of a gas is directly proportional to number of atoms or molecules present. Volume of a gas directly proportional to number of atoms or molecules. Okay, in these two conditions, pressure and temperature, you have to kept constant. At that time, the volume will be directly proportional to number of atoms or molecules present. Okay, volume depending upon the number of atoms and molecules, the volume will be. So, V proportional to N. Here the N denotes number of atoms or molecules. And here V by N is equal to constant. V, the ratio of V volume by number of atom is equal to constant. So here you all know that this Avogadro number, that capital Na denotes this Avogadro number. What do you mean by this Avogadro number? The total number of atoms per mole of substance. For 1 mole of a substance, how much number of atoms are there? That denotes this Avogadro number. Na represents Avogadro number, the total number of atoms per mole of the substance. For 1 mole, how much number of atoms are there? That is Avogadro number, and this value is constant value 6.023 into 10 to the power 23. For 1 mole, how many number of atoms are there? 6.023 into 10 to the power 23. Okay, this three definitions, 3 laws, very important 2-mark question. Okay, Boyle's law, Charles' law and Avogadro law. Okay, in the Boyle's law, temperature is constant. The Charles' law, what is constant? Pressure is constant. Okay, and the volume is directly proportional to temperature. And this Avogadro law, pressure and temperature is constant. Volume is directly proportional to number of atoms or molecules present. Now all of you take your book. We are going to mark the questions. Roman letter 6 Already first question last class we marked. Now the second one, distinguish between linear, aerial and superficial expansion. Take page number 34, 35. See page number 34, linear expansion. When a body is heated or cooled, the length of this body changes due to change in temperature. This is called linear or longitudinal expansion. Here the coefficient of linear expansion definition is here. That one second point you mark it. If it is 4 mark question means you should draw the diagram also. Okay, below the diagram you have to write this equation. What's the equation? Delta L by L0, alpha L into delta T. Then what is this delta L represent? L0 represent delta T. L0 original length, delta T be the change in temperature. Okay. Then next page, superficial expansion. First paragraph, there is increasing area of a solid object due to heating. Then the expansion is superficial or aerial expansion. Second point, what is coefficient of superficial expansion? You have to write. And next one, diagram. Below that you have to mark this formula. Delta A by A0 is equal to alpha into delta T. What is delta A? Change in area. A0 be the original area and change in temperature. Alpha A, coefficient of the superficial expansion. The third one is cubical expansion. First paragraph, there is increase in the volume of a solid due to heating. Then the expansion is called as the cubical or volumetric expansion. And below that, the cubical, what is coefficient of the cubical expansion? Here, from the third line, the ratio of increase in volume of the body per degree rise in temperature to its unit volume is called as the coefficient of the cubical expansion. This is measured in Kelvin power -1. Next one, this equation also you have to mark. Delta V by V0 is equal to alpha V into delta T and up to this, okay, coefficient of cubical expansion. Third question, what is coefficient of the cubical expansion? Coefficient of cubical expansion. Take page number 35. The ratio of the increase in volume of the body per degree rise in temperature to its unit volume is called as the coefficient of the cubical expansion. Up to this you mark third question. Next question number 4, state Boyle's law. Take page number 36. Okay, next fifth question also same page numbers. 36, state Boyle's law. Next question, volume, state the law of volume, page number 37. Boyle's law, page number 36, mark this paragraph. When the temperature of a gas is constant, the volume of fixed mass of a gas inversely proportional to its pressure. P proportional to 1 by V and PV is equal to constant. Next question, state the law of volume. Charles' law only, it is also called law of volume. Page number 37. Page number 37. Mark this paragraph. Charles' law is formulated by French scientist Jacques Charles. According to this, here to mark, when the pressure of a gas is kept constant, volume of a gas directly proportional to pressure of the gas. V proportional to T and V by T is equal to constant. Up to that. Question number 7. What is coefficient of real expansion? Page number 36. Question number 8. What is coefficient of apparent expansion? Same page number 36. Page number 36, question number 7, coefficient of real expansion is defined as ratio of true rise in the volume of liquid per degree rise in temperature to its unit volume. The SI unit of coefficient of real expansion, Kelvin power -1. Okay, next question number 8, what is coefficient of apparent expansion? This paragraph. Coefficient of apparent expansion is defined as ratio of apparent rise in volume of the liquid per degree rise in temperature to its unit volume. And this SI unit of apparent expansion, Kelvin power -1. Next Roman letter 8, detail answer. Second question. First question, next class I will take. Second question, explain the experiment of measuring the real and apparent expansion of liquid with neat diagram. Take page number 36. Page number 36, experiment to measure real and apparent expansion. From here to start, the liquid whose real and apparent expansion is to be determined is poured in the container up to a level. Mark this level as L1. Now heat the container and the liquid using the burner. Next, initially the container receives the energy and it expands up to this diagram. Okay, up to this diagram you mark. It's very important, 7 mark question. Okay, up to this diagram mark it and learn. Today's homework portion, Roman letter 6, question number 2, 3, 4, 5, 7, 8 and Roman letter 8, question number 2. Learn all these answer, okay, and you have to write in the note the following questions. You have to study and write in the note. State Boyle's law, state Charles' law, and explain the experiment of measuring the real and apparent expansion of liquid with neat diagram. Okay, this detailed answer with the diagram you have to learn and write in the note. Thank you.